this, please write today's date. This is specifically, write exponential. Remember, logs are another way to write exponential equations and expressions. And the first one says writing an expression that represents the sum. Let's circle the word sum. It means we're adding up. It represents the sum of the first 16 digits in this sequence. So this is what you have to have memorized. So the first number in this sequence is 3. How do I figure out the rate? I take the second number, divide it by the first. 12 divided by 3 is 4. So, and then I want to do the first 16, so my n is 16. So I'm going to rewrite this with these 3 in place of a sub 1, r, and n. So a sub 1 is 3, so I have 3 times the quantity, 1 subtract 4 over 1 subtract 4 raised to the 16. Grab your calculator. Remember not to take a calculator from up here because it doesn't have one of the programs we'd like in the same way. So I'm going to do 1 subtract 4 to the 16th, get an answer. Make sure when you divide, you're going to put in parentheses again 1 subtract 4. If this is not in parentheses, it will not do the operations in the correct order. You'll get the answer wrong. Take a times a 3 out front, and there's our answer. Hands raised if you have the same answer on your calculator so we can see it, okay? So I'm going to write this number down, very large number. Okay, at this time, please do me a favor. I want you to highlight number 1 right here or put a star. A star means I am 100% sure I can get that on correct on a test. I'm confident a week from now, or I should review it. Okay, the next part says write an expression that represents the 13th term in this sequence. So that's term 1, 2, 3. Okay, this is the same one as up here. So I know that the rate is taking the second number divided by the first. 12 divided by 3 is 4. So I'm going to multiply by 4. I'm going to let the calculator do the work. I want to get to the 13th term. Times 4, there's 12, times 4, that's your third term in the sequence. After you do something twice, the calculator recognizes the operation. There's 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11, 12, and 13. This is not asking you to add up the first 13, it's just what is the 13th term. This is asking you to add the first 16 terms in the sequence. Okay, please grab this. And in the packet, please turn and find problem. Oh, give me a second here. Please find right now problem number 9 and problem number 10. On your own, complete the problems and then check your answers with mine. At this time, only 9 and 10. Begin. did the last one two different ways. One is I just used the calculator to do the common sense way. I started taking 6 times 3, following the rate, times 3, following the rate, and I continued to do that until I got to the 23rd term. Here's my answer. Another way to do this, so you could take each one of these and find out which one is equal to this value. Another way to do this is to know this formula. If you don't know this formula, that's something you definitely need to know. This is when it gives you a list or a sequence. This will help you find a number within a sequence. That means within a list of numbers, you can identify a particular term. This is not adding them up. This is like, tell me the 5th term or the 4th term. This is not to do with graphing. This is simply to find a number within a list. Okay, go back right now. Please highlight 9 or 10 if you need to know that. I'm giving you a heads up that, 1 second here, please. So this number here, for instance, if you had to right now rewrite this in this form, what would it look like with your partner? How would you rewrite this sequence in this type of form? Okay, go ahead. You have 15 seconds to begin with your partner. I came up with an answer of 3 times 4 raised to the 12th. Let's see if that equals this amount. 4 to the 12th times 3, it is the same amount. So what if you're like, oh, I forget on the day of the test how to do this, but you can come up with this amount? Well, if they give you multiple choice options, such as this, then find out which one of these options equals the quantity that you have achieved. Let's go on to number 3. Number 3. Remember the disco move, yes? Do you guys remember the disco move? Okay, it looks like this. This is in logarithmic form. If we rewrite it in exponential form, it looks like this. The base is 2. You raise it, taking your disco move all the way across the equal sign to the opposite side, to the n minus 5 equals an answer of 17. I just rewrote it in exponential form. It does not ask me to solve. Base raised to the opposite equals the answer. Base raised to the opposite equals the answer. Please go ahead and put a star or highlight this number. Star or highlight. Going on to number 4. So in number 4, we are asked which one of these is equivalent. So I'm going to go step by step, and we'll just come back and look at our answers here. So my goal is to first isolate the number e, bless you, so I can eventually solve for this x. So let's first do this. I know 40 subtract 18. What is 40 subtract 18? 22. Then I'm going to ask myself, should I first get rid of the 22 or the negative 12? You're doing PEMDAS backwards. Please excuse my dear Aunt Sally. You're doing this backwards in order to solve for the variable. So let's first get rid of things that are added or subtracted on the same size as the variable. So I'm going to add 12 to both sides. Make sure you're showing your work on your paper right now. 74 plus 12 is 86. And our goal again is to isolate these. So let's divide by 22 next. And now take a calculator and go 86 divided by 22. And is it a nice decimal, or do we need to put it back into a fraction? Oh, it's not very nice. It's ongoing, even though we can predict the next number. So let's hit math fraction, enter, enter, and it will reduce it for us. 43 over 11. Okay, we're getting closer. Now, when you're solving for a variable that's in the exponent position, that's the only reason why we learn logs. So I'm going to do the log on both sides and I'm going to do the log of whatever number I'm trying to get rid of. So log base e on both sides. On the right-hand side, log base e and e cancel. And I'm going to come right up here and show them the next work. So now I have log base e. Does anybody remember? Look at these options here. What's another way to represent log base e? So I have the ln of 43 over 11 equals negative, and by the way, I don't see any 0.25. Oh, I do see a couple 0.25s. Okay. Equals negative 0.25x. Okay. Last step is to divide by exactly what I see. Now remember, when you divide, it's really like multiplying by the reciprocal. So watch. I come over here, it's like multiplying by the reciprocal, negative 0.25. And I'm going to multiply over here by the reciprocal, 1 over negative 0.25. So that's the way they cancel. Remember, they really turn into ones. And I have x equals 1 over negative 0.25 times ln of 43 over 11. Okay, let's look at our options. I need a negative 1 over negative 0.25. So anything that's not negative, I get to cancel out. Anything that's not negative, I cancel out. So I've already eliminated b and e. Now let's make sure they all have an ln. So the 4 remaining options, this is not an ln cancel, not an ln cancel. I'm down to 2 options. What's the difference between these 2 options? They look very similar. Turn to your partner, what's the difference? In this situation, your calculator would be taking the ln of this quantity. That's what we want. But down here, take just the ln of 43 and it would divide simply by 11 afterwards. We want the ln of the entire thing. Correct answer is D. 3 is the reverse of number 5. 3 is the reverse of number 5. So I want you to do log, and I want you to make your boxes. So whatever the base is here, which happens to be the number e, becomes the base again. This is your answer. Your answer is 7, so it remains afterwards. So it's base raised to the opposite, base raised to the opposite, equals your answer, equals your answer.